Finish all of this. Question 1 on the review is to find the cosine. Some of you made this out to be a lot harder than it needed to be. Okay, you guys, make sure you're getting these answers right, so pay attention. Even if you're not finished, just stop where you are, look up at question 1. Cosine is adjacent over hypotenuse. If this is where theta is, this is the adjacent side, 3 squared roots of 21. What's the hypotenuse? 17. That's the answer. 3 squared roots of 21 over 17. Okay? You don't have to simplify it because you can have a squared on the top of a fraction, you just can't have it on the bottom. So you don't have to do anything on that.
What do you do if you have it on the bottom?
If it were on the bottom, let's say it was like 3 over 3 square roots of 21, then you would multiply it by the square root of 21 over the square root of 21, if that's the case. Okay? Question 2, again, I think some of you made this out to be harder than it needed to be.
It's not harder than we need it to be, guys.
So the question here was asking for the tangent of theta. Definition of theta is opposite over adjacent.
You mean over tangent?
The definition of tangent, yeah, is opposite over adjacent. The opposite length here is 15. The adjacent length is 8, so it's 15 over 8, and you just leave it. Okay, you guys. Thursday is test day. So if you have questions, now would be a good time. No questions? Okay, question 3. I saw a lot of you struggle on this one. Find the sine of theta if we know that the tangent of theta is equal to 8 over 15. Now,
8 is opposite, 15 is adjacent.
On this one, I would just draw a random right triangle and put theta somewhere. I'm going to put theta here, for example.
15 goes along, 8 goes on the bottom.
Now, the tangent is opposite over adjacent. So if this is where I put theta, that means 8 has to go here and 15 has to go here. Now if you do Pythagorean theorem, a squared plus b squared equals c squared, you would find that the missing side here is 17.
What's that called again?
This is one of those Pythagorean triples. Yeah.
Once you get a squared plus b squared plus c squared, about 2
You do a squared plus b squared equals c squared. A squared, either one of these could be a or b. So if this is a, then that squared is 225. B squared is 64, that equals c squared. That's 289, and that equals c squared. But we want to find c, not c squared, so I had to get rid of a square. Square root. So if you square root, you get 17. Now, why did we have to know that that side was 17? Exactly. We have to know the hypotenuse. The definition of sine is opposite over hypotenuse, so the answer is just 8/17. Question 4. Find cosine of A. Hold on. Cosine of A if we know that little c is 25 and little a is 20. Again, I would just draw a random right triangle. C, big C has to be this right angle. So this could be A here and that could be B there. Across from big C has to be little c, that's 25. Across from angle A, I have to put that as 20. And then we got to find this. Well, yeah, we have to find this angle, or not that angle, but we have to find this side right here.
Oh, so I got it right. Oh my goodness.
What is that side? We're going to do Pythagorean theorem.
What's your question?
And it turns out to be 15. How do we know it's 15? Pythagorean theorem. A squared plus B squared equals C squared. This side turns out to be 15. Why did we need to know this side? Because we're doing cosine, which is adjacent length over the hypotenuse length. So the cosine of A is 15 over 25. I would feel bad doing this, but I would dock off a point if you just left your answer as this. Not as a hexagon. Why would I dock off a point?
Cosine of A.
It's not that I didn't write cosine of A. That is true, I didn't write cosine of A, but
Simplified.
it's got to be simplified. It's 3/5, you guys. It's 3/5. That's page 1. Trust me, this is the easy page of the exam. Okay? So some of you, I think, who may not have maybe had to study as hard for previous tests, you might need to study a little more for these. If all you do is do this, and then you go home and do nothing on Tuesday night and Wednesday night, and then you come Thursday to take the test, do you think you're going to be as ready as you could be? No. No. And we aren't reviewing on Thursday, nor will I answer any questions. It's testing time. Yes. We're working on the review right now. So, actually this one might be, now that I think about it, maybe a little easier than the blue one.
Flipping it over again.
Flip it over to the back. We're going to do 3 problems on the back, and then you can turn to the front. Okay. Flip it to the back side. Come on. We're running out of time here. Here's the first problem I want you to solve. Problem 1 on the back side of the pink page. Draw a right triangle like this. Not like that. Okay, let's try that again. That's better. Let's put the top angle up here is 41 degrees. The hypotenuse, let's put that at 11. And then put an X down here. And the directions would be to solve. The directions would be to solve for X. This is like problem number 1 on the pink page. So the ones on the blue could have, I guess, been done without a calculator. These ones cannot be done without a calculator. This is one of the assignments we've done. 3 times we've done problems like this on 3 different days. Which trig function matches the situation? Y sine. You are right. In relation to this given angle, this is the opposite side. This is the hypotenuse. Opposite and hypotenuse only means one thing. Sine function. So the sine of 41 is equal to the opposite length x divided by the hypotenuse 11. So sine of 41 is x divided by 11. We're solving for x. X is being divided by 11. So how do we get rid of dividing by 11? Multiply by 11 on both sides. Exactly. X equals 11 times the sine of 41. Which on a calculator, 11 times the sine of 41 is 7.2. So I guess this, maybe this pink page, these probably seem to be a little bit easier than the blue. Here's the second one. Let's put this angle up here at the top is, let's say it's 54. This side here is 9, and now we don't know the hypotenuse.
They're all the same.
That's what
No,
the test
like,
is gonna be like.
they're all like different.
The test is gonna be hypotenuse.
You should look at this about all of
We don't know what we look like.
Can we use sine here again?
Yeah, no. We can use adjacent over hypotenuse.
Adjacent over hypotenuse is not sine, it's cosine.
Adjacent over hypotenuse is cosine. So this has got to be the cosine of 54. But here's the problem. It's not really a problem. Here's the difference, though. X is on the bottom.
That big, you have to do something.
Again, we have done a lot of problems like this.
Multiplied by x on both sides. So now we have x times the cosine of 54 is equal to 9. We're still solving for x, though, and we don't know what x equals.
We have to get x by itself to get by cos.
Divide, not just by cosine, we divide by cosine of 54.
Which they would make x
9 over cosine of 54.
Which they would equal 53.
Which is 15.3. Both of these problems involve finding a missing side. This third and last problem we're going to do together, then you guys can flip it to the front, involves finding a missing angle. So if you have theta, theta means we don't know the angle. But if we knew that this was 3, and if we knew that was 7, how would we find the measure of angle theta? You have to remember this, and I've said it a dozen times. If you're finding an angle measure, you use inverse.
So trigonometry,
You have to start with a normal equation, and then you end with inverse. What were you going to say?
I just have a question on the last one. I don't get why you divided cosine.
Because x is multiplying the cosine of 54. And the opposite of multiply is divide. Now we can't divide by cosine of nothing, but you can divide by the cosine of 54, because the cosine of 54 is just a number. And all we're doing is dividing by a number. It wouldn't be correct just divide by blank cosine. That doesn't work.
Are you trying to get x by itself?
Yeah. That's what we're solving for. Now, sine, cosine, and tangent. What fits here? Why is it tangent? This is the opposite side here. That's the adjacent side.
yes.
So the first you have to set up the equation. The tangent of theta,
Opposite over adjacent, which is 7.
opposite over Jason, which is 7/3. But
We can't stop here because we still don't know what theta equals.
So it'd be tan minus 1.
We're doing the inverse.
We're finding theta.
you can't just divide by tangent to get rid of tangent. But you do inverse tangent. So theta is the inverse tangent of 7/3, which on a calculator, inverse tangent of 7/3 is 66.8 degrees. So turn to the front. This is question 1 on the pink one. You had an x here, 7.7, and we knew that this was 33. So cosine of 33 is 7.7 over x multiplied by x on both sides. So you have x times the cosine of 33 equals 7.7. Now divide by cosine of 33. We want to get x by itself. And that's gone. So x is 7.7 divided by cosine of 33, which is about
15.
9.2. Question 2. The triangle is flipped a different way. This is 61. We don't know the hypotenuse, but we know that this is 3.9. This is another cosine. Cosine of 61 is 3.9 over x multiplied by x on both sides. So x times the cosine of 61 is 3.9. Divide by the cosine of 61. So we have x equals 3.9 divided by cosine of 61. That's about 8. Question 3. This one is 8. That one was 8.9. You're supposed to find the measure of the missing angle. If you're trying to find the measure of an angle, you're going to eventually, at the end of the problem, have to use inverse trigonometry. You start with tangent of theta. Because this is the opposite side, that's the adjacent side. Tangent of theta is 8.9 divided by 8. Now we got to get rid of tangent. The only way to do that is to use inverse tangent. So theta is the inverse tangent of 8.9 over 8, which is about 48 degrees. Question 4. Let's see, this was 13.7. This was 11. We're trying to find theta here. This is another tangent one. They're not being very creative. It's the same function again. Tangent of theta is opposite over adjacent. Use inverse. Theta is the inverse tangent of 13.7 over 11. That's about 51.2 degrees. Here's a problem you're solving on the back side. Back side of the worksheet. There you go. We ready?
Are we getting points for writing everything down on that thing?
So random triangle here. Label the right angle as C, and then put an angle A here, and an angle B there.
Does it always matter with being air?
No. Angle C has to be the right angle. Let's say that we know this is 40 degrees. And we know the hypotenuse is 14. The directions here, and this is exactly how it's going to read on the test, is to solve the triangle. We did an assignment like this. It was actually green as well as this. Solve the triangle. What does that mean? Find every angle. Find every missing side. So angle A, angle B, and angle C, those are the capital letters. And then the lowercase letters are the sides. I would start with what you know. What do we know?
We know
C is 90,
A is 40.
and A is 40. There's one more thing we know.
That C is 14.
That little c is 14. We know that. Now, for me, I'd start with the easiest thing to do here. Find the missing angle. That would be the easiest.
So do 90 plus 40 and then subtract 180 is 250.
Did you guys follow that? We know that all three angles of triangle add up to 180, so if we're just missing one, add the other two and subtract it from 180. So it's 50. So that would be where I would start. We know angle B is 50.
And now we can find B first, little b.
Now we can do A or B. Sounds like you want to do B first.
Yep.
So this is where we have to use trigonometry. If we only know one side, we can't use Pythagorean theorem if we don't know the other two sides. So
using the information that's given, let's say that we have this 40-degree angle, we have the hypotenuse. What side is B? Opposite adjacent? Which one? It's adjacent to 40. And then we have the hypotenuse. So what sounds like adjacent and hypotenuse? Cosine. So to find B, we can use cosine of 40.
Cosine of 40 is equal to B divided by what? 14. And then if we're solving for little b, b is being divided by 14. We're not solving for the angle. We already know the angle. We multiply 14 the other side. Good. So b is equal to 14 times the cosine of 40. 14 times the cosine, 10.7.
Oh, man, I'm getting closer with my guesses.
Yeah.
So little b is equal to 10.7. We did b. On the calculator, it's just 14 times the cosine of 40. How do we solve for little a?
Use the
You actually have two choices, and either one would be fine. You could do Pythagorean theorem now, right? Because we have two sides, just finding the third. So if you wanted to, you could do Pythagorean theorem. Or if you wanted to, you could do trigonometry.
What would you do?
I would do another trigonometry.
Well, since he has a calculator.
Pythagorean theorem would work, but since we rounded 10.7, if you use 10.7 in Pythagorean theorem, and this is rounded, then side A is going to be a bit off.
That is okay.
A little bit. I'd still give you points for it, but it'd just be a little inaccurate because we're using something here that's rounded. You guys understand what I mean?
Yeah. Something what if you just went around it? Like didn't round it.
You have to round it because it's a decimal that never stops. It's 10.7246222. I mean, you could use all the decimal points if you want. Man.
So you would have to type that in the calculator if you're doing Pythagorean?
No, you would just round to 10.7, but that means your answer here is going to be slightly off by
What if
10.
you just write 10.7246?
You could if you want.
It's good to round up one way on one number and then round down on the other.
So I'm going to actually use trigonometry. If I'm going to solve for little a right here, then isn't this across or opposite from angle 40?
Yep.
And this is still the hypotenuse. So what's opposite on hypotenuse? Sine. So now I'm going to do the sine of 40 is equal to a over 14. It's actually probably a little faster than doing Pythagorean theorem because all you got to do now is multiply by 14 on both sides. So a is 14 times the sine of 40. That's 8.999, which is essentially 9. So a is about 9. Yeah. Oh, this wasn't drawn according to scale. I think that's the only practice we need on solving a triangle. That's what it means to solve a triangle. So turn it to the front now. Get going on a few of those.